So, hello, I'm Ken from Axon Networks. I work as a DevGitOps engineer, and I'm also responsible for our cloud platform's observability stack. So today I'll be presenting about our use of Pulsar, how we established its observability, in which we have a matter of high topic cardinality. It's in the field of telecommunications, and how we manage this stack as a company and as platform teams that goes by GitOps principles. Now, before I start, a bit about myself. I'm primarily an integration engineer who has architected and developed distributed systems and software solutions on them now more than the last decade. And as I've said at the start, I'm currently a DevGitOps engineer with Axon Networks and maintaining the observability stack for our cloud native platform there. So, for today, I'm going to be going over three main topics, and the first one is how we are using Pulsar, and it'll be a summary because I had emphasis on these points in our the previous summits. So the first part will be the story so far as to what we've been doing, what we've developed, and the second part of it is, well, why did we have the need to develop such a custom solution, and what were our restrictions, and how we deal with them going on. So on the second part, it's essentially our tooling requirements in essentially developing this custom stack, what it plays as a part in our platform, which centers around Pulsar. And I'll be going over the details with regards to how we maintain to develop and deliver this stack and its use. And on the third part is our basically GitOps journey. So we manage our stack by GitOps principles. However, as we were onboarding the observability stack, we had certain challenges, and still going forward we have other ones. So this part is with regards to how we got creative in incorporating certain parts of our stacks, which is quite large at this point. So basically what we've done with it, what we're doing with it, and what will be continuing to in the way how we evolve it will be what's in that last part. And as time allows, I'll try to answer your questions. Alright, so let's start with the story so far. We have a cloud native platform that uses Pulsar as its event fabric. The platform basically provides functionality for the next generation of virtual CPU onboarding with a secure access service edge model. In essence, it is for the management of a CP digital twin in the cloud platform. And the digital twin belongs to the devices that we are manufacturing. And the secure access service edge is established using our own proprietary protocol that we call the vEdge through mutual TLS. So with this, each one of the CPs that we have their own private channel with the cloud. And that, communication side, system load side, it has a challenge on its own. But in terms of observability, in terms of maintaining the monitoring and doing alerting on a per CP basis, it brings quite the challenge. And we faced that challenge early on, in which for say around 2,000 channels, we had issues because we had went ahead with standard tools in any IT project, in which we first went ahead with the Kubernetes stack, then explored our options with Cortex, Mimir, Victoria Metrics, and finally M3, and well, we were not able to get the results we wanted out of them. Essentially, now at the time, it was a channel per device. During the life cycle of the platform, this can be 3 channels per device. And so essentially, at 2,000 channels, the metric backend would lose its robustness. And at 5,000 channels, which is essentially 5,000 topics, which are in essence metric labels, we'd see the metric backend starting to break down. And when we were trying to identify the problem, because we'd end up with the whole metric backend itself breaking down and losing, we'd end up losing all the visibility we'd have on the platform. So with that, we had identified our issues span from a lack of granular control of how we do our labeling and how we end up with processing power being wasted on trying to infinitely scale the metric backend. And at the core of our issue was the high cardinality. We'd end up with our channel labeling, which is essentially our a proprietary format of serial numbers for our devices. Now, we went ahead and resolved this issue by employing Grafana's agent stack. It's a heavily custom implementation, and we've done a form of metric series filtering in which we selectively filter out metric series from the brokers at the agent level, so that we don't really be bringing in what we need. This in turn turned into a strategy of basically spinning up agent instances that would keep only a single metric series, which we now call as a Pulsar broker single series, or PBRS metrics in that regard. And in handling the serial number itself, we basically employed a form of relabeling in which we reduced cardinality by treating what we had as our serial number as a form of pseudo subnet, so that from a possible million unique values, we'd reduce it to distinct labels that would have their highest values at being, 100 unique values, etc. Now, when we transition to this format and the number of devices being onboarded increase, we start to see an issue in which, as I listed down, we have a form of single series metrics, and that means singular agents, which at a time would mean that we end up with 40 different agents for each one of those series coming in and trying to scrape metrics from a single broker that is already loaded in handling these channels. So we put what we call as a metric exporter proxy and its operator in front of our brokers to spin them up, so that this MEP, as we call it, would get the initial payload from the broker. Then our agents would subtend to it to actually bring that, which ends up reducing the load on the broker as well. Now, we are continuing to extend our implementation so that in which we are building a metric pipeline to do other forms of grouping to reduce the processing power needed there because our agents grow to become memory hungry after some point as well. And going forward, we actually need to be able to simulate scenarios in which we have something that would be similar to a production cluster running during our development time and build time to continue on with our work. So now, the whole idea as to why we are doing these is to have a single glass of observability on our event fabric and the other components that we have, such as our microservices, databases, our ingress. And when we are trying to build that single glass of observability, it all pretty much centers around a per device aspect and its channels. So when, say, we have a metric, a log, and a trace component, the keying is again done on a per device basis, because at the end of the day, the digital twin maintains a customer device, and whether it be an outage or an issue, we need to be able to drill down to actually to the device level itself to do our root cause analysis with it. So within that perspective, we need to maintain a single glass of observability. And beyond this, we need to have event sourcing for the elasticity and resilience of our platform, so that, say, based on the backlogs that could be occurring on a per device or the platform's ingress or service-driven other queues, we want to be able to trigger scalability of our components so that we operate both at optimal cost and be able to sustain a form of self-healing when things go sideways with it. Now, to establish that, as I had described in our initial form of how we are maintaining our observability stack, we basically have a pull-push kind of configuration in which we have our observability agents that send in what they collect in the form of metric agents. It's the metric data, and for the logs, it's the log events. For tracing, it's spans, and for auto instrumentation based, it's again a pool-based collection that gets sent back into the metric backend. Sorry. Initial to the tracing backend, then from that we generate metrics out of it to be sent back into the metrics backend. So this, at the end of the day, are distinct group of components that form a stack. However, when we are both doing our development as well as deploying it in the form of various flavors, where we might have upwards of 10 different clusters that need to be submitting all this data into a singular observability cluster, or it's just a standard in-cluster form, we need to be able to maintain the alignment of the stack. And it's a challenge, and as I've said, when we develop something, it does not go into a production that is, say, a small one, but rather somewhere where we are already hosting at least 100,000 devices per shard. So, to maintain the level of synchronization and manage various flavors and sustain fail-fast testability for the high cardinality scenarios, well, our hands would get tied in classical forms of, say, going for things like compose-based setups or minikube-based setups. Now, before going into that detail, I want to put an emphasis on a development effort in which we were struggling with standard ways of maintaining our tooling. So for the metric exporter proxy, it's for so initially we had compose based setups where we'd spin up standalone instance of a Pulsar, then a dummy service, then we started to extend it, then well, we had the need to develop the metric exporter proxy, in which we'd be proxying the metric. So we need to set up part of our agent stack there, and well, it sort of grew out of control. So we went into how we design a sort of ephemeral environment where we keep certain components in place while changing the other ones. So as DevOps, we maintain builds and pipelines, build environments and pipelines for developers. So what happens when a DevOps needs an environment and same kind of pipeline to maintain their tooling that they are developing? We'd set up pipelines to build them, and we'd need to target environments. However, by the nature of what we are developing here, we have levels of dynamism and certain amount of load in the environment that needs to be sustained to be able to simulate the problem that we are trying to solve with it. So our initial setup of just running a few containers by ourselves evolved into a form of compose-based setup that was started to span 2 different nodes. And when we start to go into the metrics group filtering, we need to sustain a certain load on the Pulsar itself to be able to have the target for developing and testing some of the feature sets we have for it. And when logging and tracing aspects of these came into place with our components ever growing more complex, as well as our need to keep the cloud native aspect of them, because at the end of the day we deploy these into Kubernetes clusters where our Pulsar is operating as well. Well, we needed to adapt, and in that sense, so and beyond this, we had a need for maintaining our different deployment profiles in the form of how we'd have distinct workload clusters in place where the agent setups we've had not only for the Pulsar cluster itself, but specific microservices that would operate on there would shift, and based on those we need to go for specific profiles of deploying our agents, and as I had mentioned midway through, as we have been evolving our stacks, is not just the Pulsar broker single series, but the Pulsar client metrics that we are generating out of our microservices. That was great. And for those, for the sake of single class of observability, we need to consolidate them, do the similar processing on them. So we need to simulate them as well, because we have different profiles for different target workloads, for different device families. So we end up with a multi-target deployment management complexity where we need to employ different flavors of our deployment. And to that end, even though we had evolved the stack to be maintained as a Helm chart that we could deploy through Argo as its different flavors, we end up passing through the limits of what we could do with the Go templates. So from compose to Helm-based deployments, employing Argo to deploy them, we run into certain limitations. And we also end up with quite the fragmentation with part of our test setup being stuck in the compose for tracing, or with some of our deployments, specifically some of the legacy deployments, as we call it, for some of the clusters that had been running for more than a year, where we'd have specific helm commands in place, but they are not fit to be, say, run through Argo using the current bootstrap mechanisms that we have in there, which we already employ for our workload deployments, which includes various third-party infra components as well. But as we got limited, so we are both limited by the templating part, and we also, due to the level of extensions we have over our templates, can't really run it in a GitOps way. So, and we also have an underlying complexity of our components and dealing with release fragmentation. Still going ahead with Argo, but this time Argo's rollouts. We want to take a programmable approach, and as we had been trying to transition into at least generating our values file for our templates, start to go the route of trying a programmable approach to create those values file by custom structures, and seeing that we could reuse those structures and basically render out our templates through CDK8s. We start to look into how we deploy them. Should it be just a single job? Well, we already were employing Argo, but the bootstrap mechanism there is for addressing a singular binary and different template types. Now, Argo rollouts has the built-in capability to actually embed the CDK's binary to render out our various different structures to consolidate them, and this consolidation part is important both for the different agent families that we have. We need, so we can both do synchronization between different agent families, and when we say something like an agent family, it's basically a scraping agent or a log collection agent that operates on certain group of microservices, or in the case of our Pulsar broker single series, it's operating on those singular series, and we need to maintain the synchronization between the labels that we have for the original metrics from the standard scraping and metrics that we generate out of our logging events. Because at the end of the day, when we take these, we have composite visualizations through these metrics. For example, we track the inflow of our messages and per device impact on the resource usage, as well as whether if a device is sustaining its throughput. So those are part of what we visualize, especially for our business executives to keep track of, as well as to maintain the health of the system when we are doing alert evaluations based on them. And at the end of the day, as we are transitioning into the programmable approach, we are able to operate out of a single source of truth for our deployment flavors as well. So we basically have a superset of every one of the agent types that we have and the deployment types that we have for them, in which it's either a common group of agents being deployed or a mix of them being deployed. And when we are targeting the metric backend for it, we have what we call as a metric tenant that belongs to an agent family, which can be the entirety of the metric series from microservice or Pulsar's Zookeeper, Bookkeeper, or Proxy, or for the Pulsar's broker itself, it's essentially single series metrics that target a metric backend tenant, and we are able to directly with the flags that we keep in, we can generate the entirety of the stack from a singular code base in this way. So now the testing aspect. Due to the nature of some of the components, especially with the tracing, where we are specifically testing out eBPF based auto instrumentation, some of the newer tools that we investigate have been proven to be invasive on the environment, so we would not be able to fully utilize the clusters that we've had or that we are maintaining on the cloud, because we essentially need to tear down the cluster and rebootstrap it due to the impact of those diverse tooling. So with that, as we were moving from Compose-based setups into Minikube, then into Kubernetes in Docker, well, we discovered that the Submariner actually works in connecting Kubernetes and Docker clusters as well. So what we are doing right now is essentially dividing up the database Pulsar, the Argo rollout, and the observability target into 4 different kind clusters to have these separate components and interconnect them with the Submariner and do the targeting with the Submariner suffixes, so that the traffic is connected in between those 4 kind clusters. But well, if something goes down wrong, we can basically tear down that singular cluster and rebuild it back up and be able to fail fast in our prototyping the new features, as well as be able to maintain a cluster, Kubernetes cluster compatible development environment that we can fail fast in. So, okay, that's basically where our GitOps journey is leading us into. This is something we've been establishing for our metric site, and something we're thrilled to especially be doing for when we are setting our tracing part of the, well, rest of the tracing part of our observability stack. So that sort of wraps up. So that's about it. And if you have any questions, feel free to write them in the chat. I'll try to answer them as much as our time allows. And in the event that if you have any more questions or those that I may not have been able to answer from the chat, you can reach out to me to ask about them. And with that, I thank you for sparing the time to listen to my talk and for your patience, obviously, as it was essentially compressed information in a short duration. And as one last thing, special thanks to my team at Axon Networks, which is us, the platformers. Have a great day.